Welcome to my algebra class. We're on chapter 10, section 7. We're going to be working with inequalities in two different variables. So we're going to be on the coordinate plane. If I draw a line on a coordinate plane, it divides the plane into three sets of points. Everything above the line, and that's considered a half plane. Everything below the line, that's a half plane, and the actual points on the line, and this is considered a boundary. So if we have closed and open half-plane solutions, what we're going to do to all these inequalities, we're going to make sure we change the boundary equation into slope-intercept form. Graph the boundary equation. We will use a solid line if the inequality is less than or equal to or greater than or equal to, because that will include the line. We'll use a dashed line if it's less than or greater than, because the line is not included. And then we're going to shade the appropriate region. And we can always pick an ordered pair in that region that we shade to make sure it solves the inequality. So the first example, y is greater than x plus 3, it's already solved for us. It's in slope-intercept form. So the boundary equation would be y equals x plus 3. The intercept is 0, 3. Remember, slope-intercept form is y equals mx plus b, and this number here is the y-intercept where it crosses the y-axis, and m is the slope that tells us how to move from that point. So we're going to graph 0, 3. That would be that point here. The number in front of x is 1. That's a slope of 1, so that means up 1, right 1. And then we draw a line through those points. And it's going to be a dashed line since it's greater than. And the area we want to shade will be greater than would be above. So we'll shade this area here. And I can pick a point from that area. For example, this point right here, which would be 1 and say 1, 6. So if y is 6 and x is 1, 6 is greater than 4, it works. So that's an open half plane. It's open because the line's not included. Okay, y is less than x plus 3. Basically, we would just repeat the same process here. It's at 0, whoops, I gotta find the right line here. It's 0, 3 is our intercept, up 1, right 1. And again, it's a dashed line. Let's use that. And it's shaded. Just remember there's arrows at both of these ends. These are lines. And it's shaded less than would be below, so it's shaded underneath. It's everything underneath this line. So I could pick this point right here, and that, let's just say it's 2, negative 2. And if I put negative 2 is less than 2 plus 3, that works. So I have the right plane. And these are examples of closed half planes. It's the same inequality again, so this would be y equals x plus 3 is our boundary equation. So we graph. There's our intercept, up 1, right 1. This time we would have a solid line. And it would be shaded, it says greater than, so we'd have to shade above. And this is considered a closed half plane because you include the number line. And the other one would be a closed half plane shaded below. So here's 0, 3, up 1, right 1. Solid line because we have less than or equal to for our boundary equation. And then shaded below. With this in mind, we're ready to start the assignment. So you don't need graph paper. You can estimate where things are going to go. It'll be fine. So we're doing 493 problems 1 to 24. Got your paper headed, and I've got to change my pen. It says the graphing inequality. So number 2 says y is greater than 4. The boundary equation would be y equals 4. So if I make a little coordinate plane here, y equals 4 is a horizontal line, the 0 slope, so we go up to y equals 4. And that's the intercept right there. And I know it's a horizontal line going through wherever y is 4, so I'm going to draw a dashed line since it's greater than. And greater than would be above. You can also use different color, you can use lines like this, so it would be everything above. That would be greater than. So if I pick any point up here, the y value is greater than 4. Problem number 4 says x is less than or equal to 1. So the boundary equation would be x equals 1, which I know is a vertical line, like a plane diving. I have to change my line here. So we're going to make our coordinate plane. And find 0, 1 on my number line. And I know the line's going to go through that. It's going to be everywhere that x is 1, which is a vertical line, and it's going to be solid since it says less than or equal to 1. So I draw a solid line. And it says we want everything less than or equal to 1, so we would be shading to the left. So any ordered pair to the left, and including the line itself, would have an x value less than 1 or equal to 1. Problem number 6, we have y is less than 0. The boundary equation would be y equals 0. So make your little coordinate plane. And y equals 0 is where y is 0, which is actually the y-axis. And it's a dashed line, so we'll have to dash the y-axis. And it says y is less than 0, so we're going to shade below. So any y value, any ordered pair I pick down here, the y value is less than 0, so that's correct. Number 8, we have x is less than or equal to negative 4. The boundary equation would be x equals negative 4. Remember, that's a vertical line again. So make your coordinate plane. And we're going to find x is negative 4. Put a point there. We know the vertical line's got to go through that. Every vertical line contains every point that has x is negative 4. And it's solid since we had less than or equal to. And it says we want it less than, that would have to be to the left. So any ordered pair to the left of that line, including that line, the x value is negative 4. Problem number 10, we have y is greater than negative x plus 1. The boundary equation is y equals negative x plus 1. Drawing our coordinate plane. The intercept is 0, 1. So we put a point at 0, x is 0, y is 1. The slope is negative 1. So that means down 1, right 1. And we check here, we can see it's going to be a dashed line. Hopefully straighter than that. And it says greater than, so we want all the ordered pairs that are above that line. And I can check to be sure I'm right. For example, I could take this point right here, which say it's negative, it's 3, 2. So if I put 2 and negative 3 in for the correct orders, I get 2 is greater than -2, which is true. Problem number 12. Y is greater than or equal to 1 minus 3x. Turn that around and get it in slope-intercept form. It'd be -3x plus 1. The intercept is at 0, 1. So we're going to plot that point, and the slope is -3. So it's down 1, right 1. So making our coordinate plane, we put a point at 0, 1, our y-intercept, and our slope says down 3, 1, 2, 3, and right 1. So our second point would be here. And it says greater than or equal to, so we want a solid line going through those points. And it says greater than or equal to, so again we want to go above. And you can double check by taking a point. For example here, that would be 3, 3. So y is 3 and x is 3. So 3 should be greater than or equal to 1 minus 9, and it is. So that works. Problem number 14. We have x minus y is greater than or equal to 3. So we have to get it in slope-intercept form. So we'll write this as we can't we can't go to the equal sign until we find out what happens to that inequality. So you solve it, get it to y something before we write the boundary equation. So it's the opposite of y is greater than or equal to -x plus 3. We're moving the x over, so we subtracted it. Multiply by a -1, that'll turn the inequality to y is less than or equal to x minus 3. So I'll remind you again, you can't just go to the boundary equation. You have to get this solved for y first, so you know what happens to the inequality. And in this case, it turned. So we're going to be shading below. The boundary equation now is y equals x minus 3. The intercept is 0, -3, and the slope, the number in front of x, is 1. So graphing, draw a coordinate plane. We plot the point 0, -3. The slope is 1, so we go up 1, right 1. And it's less than or equal to, so it's a solid line. And this is the inequality we want here. Less than or equal to would be shaded below. And I can check. If I pick this point down here, say that's -5, excuse me, +5, -5, if I plug that back in, x is 5, y is -5, it's got to come out greater than or equal to 3. So that's 5 plus 5 is 10. I've got the right shading. Problem number 16. We have 2x plus y is greater than -4. So again, we've got to get this solved for y. So we're going to subtract 2x from both sides, or just move it over. So now we have y is greater than -2x minus 4. You don't have to show that. Just move it. And that's solved for y, so now we can write the boundary equation y equals -2x minus 4. So our intercept is 0, -4, and our slope is -2, down 2, right 1. Make your coordinate plane. Plot 0, -4. Slope is -2, so it's down 2, right 1. It's greater than, so we want a dashed line. Draw it straight. I'll try. That was the worst straight line I've ever seen. Okay, maybe if I try this. And it's shaded, it says greater than, we never turned anything, so it's going to be shaded above. And you can always pick a point and double check. Number 18 is y minus 2x is less than or equal to negative 3. So I'm going to add 2x to get to the other side, so it's going to be 2x. Y is less than or equal to 2x minus 3. So my intercept is 0, negative 3, and my slope is 2, or up 2, right 1. Make your coordinate plane. Plot the point 0, negative 3. It's your y-intercept where it crosses the y-axis. Go up to right 1, so up to right 1 would be here. It says less than or equal to, so it's a solid line. And then it says less than or equal to, so it would be shaded below. Again, you can pick a point to double check. Problem number 20. We have 3y minus 2x is less than 0. We have to get that in terms of y, so 3y, add the 2x to both sides, we get 2 is less than 2x. Divide by 3, and we get y is less than 2/3 x. Since there's no number here, our intercept is 0, 0, and our slope is 2/3, which means up to 3 right. And graphing it, we put a point at 0, 0, we go up 2, and 3 to the right, up 2, 3 right. There's our second point for our line. It said less than, so it's a dashed line. And it said less than, so we should shade be underneath. So all the ordered pairs below that line. And again, you can pick one and check it. Problem number 22. We have 3y minus 1 is greater than 2x minus 7. So we have to solve for y. So we have 3y is greater than 2x. If I add 1 to both sides, I get minus 6. So I'm adding 1. Then divide by 3. So I get y is greater than or equal to, each one of these is divided by 3. I get 2/3 x minus 2. So my intercept where it crosses the y-axis is 0, negative 2. My slope is 2/3, up 2, right 3. Graphing it, we first plot our intercept, 0, negative 2. And then the slope is 2, 3, up 2, right 3. So it would be this point right here. It says greater than or equal to, that's a solid line. And greater than or equal to would be shaded above. So it's all the ordered pairs above. That would work, and also the ordered pairs on the line. And the last problem, number 24. We have 5y minus 8 is less than 2 times the quantity x plus 2y. So we're going to simplify the right side first. That's 2x plus 4y. So we want to get the y's on one side, so we're going to subtract 4y from both sides. So we get y minus 8 is less than 2x. Add the 8 to both sides. So our final inequality before we get the boundary is 2x plus 8. Y is less than 2x plus 8. So our boundary equation is 2x plus 8. Intercept is 0, 8. Slope is 2, which means up 2, right 1. Make your coordinate plane. Our intercept is 0, 8. So 1, 2, 3, 4, 5, 6, 7, 8. Our slope is 2. So that means we have to go up 2 more. And 1 to the right. And it's less than, so we need a dashed line. And it says less than, as we said before, so we're going to shade below. That concludes the evens. Be sure you check the back of the book for the answers to the odds.